Alright, let's think about circles on the Cartesian plane. Last week, I actually did the sideways parabolas. But this week, we're going to look at circles. And this will really bring us to what we're going to learn on Wednesday, which is unit circle. Alright? So the unit circle thing, you will have to think about unit circle in terms of radians this time. This one, we are looking at the circle on the Cartesian plane first. So by the end of the lesson, you should know whether a circle is function or a relation. You should be able to determine the equation of a circle with center at the origin 0, 0 and the radius of r. Determine the coordinates of points that lie on the given circles. Determine the equation of a circle with a center at the point PQ and the radius of r units. And finally, apply transformation. Now, in this case, the transformation will only be translation. We are not going to talk about dilation or reflection. All right, only translation. Now, let's have a look. This is actually a unit circle. The radius is 1. If you think about a circle, you know that every point on the circle must be 1 unit away from the origin. So it's always 1 unit away from the origin. Correct?
Yes.
Now, how do we find the equation of a circle? Sorry? Center point, okay. Center point and what else?
Radius.
Radius. What do you use to find the equation?
Pythagoras.
Thank you, Pythagoras Theorem. Because if you draw this as a right angle, you know that from the origin, the horizontal distance is x units away. From the origin, the vertical distance is y unit away. So therefore, r x squared plus y squared equals to 1 squared, which is a Pythagoras theorem. Alright? Now, normally I don't write down the 1 squared because 1 squared equals to 1. But I want to emphasize that you've got a square there. Because next slide, when I replace the radius with r, what we have is x squared plus y squared equals to r. And the two important features, or the definitive features, I'm going to circle this so that you know. When you're asked for the features, you talk about the center and the radius. The center will give you where the center is, and the radius will actually give you the whole circle, where it rotates around a circle. So for a circle with the center at 0, 0 and the radius of r, the points on the circle should satisfy the equation x squared plus y squared equals r squared. And that is actually based on Pythagoras' theorem. Alright? So important thing for this slide, the features of a circle, center and radius. If center is origin, radius of r, x squared plus y squared equals to r squared. Which means we can start looking at example 1. Alright, looking at example 1. State the equation of a circle with the center at whatever, origin, and radius of 9 units. What do you think the equation will be?
Y squared equals to 81.
Thank you. Alright, very good, because r is 9, r squared equals 81. So x squared plus y squared equals to 81. Fantastic. Now, the second one. The point 2, 3 lies on the circle center at the origin. Determine the radius of the circle. What you should actually, in situation like this, I will always sketch. So I know this is 2 and 3. So we can work out the radius equals to square root of 2 squared, this is r, plus 3 squared, which is square root of 4 plus 9, square root of 13. So therefore, the radius is 13. Not 13, square root of 13, not 13, alright, square root of 13. And if you need to write the equation, is x squared plus y squared equals to 13. Because that's r, this is r squared. Now, example 3. The point 1A lies on a circle centered at the origin with radius of 3. Determine the values of A. So again, I would suggest sketch. Let's say this is 1. Alright, you know the R is 3. Now here, when x equals to 1, you've got two values, correct? Two values of A. That would be plus A, that would be minus A. Correct? So can we determine the values of A? Of course, using x squared plus y squared equals to 3 squared. Now we know x is 1, so y squared equals to 9 minus 1, y equals to root 8 plus or minus root 8, which is plus or minus 2 square root of 2. Alright? Now, so why isn't a circle a function? One to many, thank you very much. So, if you have got a situation like this, well, I should have written that down as plus or minus 2 square root of 2. When x equals to 1, y can be plus 2 square root of 2 or minus 2 square root of 2. And therefore, it is one-to-many relationship. A one-to-many relationship is not a function, it's a relation. Of course, you can restrict the range. If I restrict the range, x equals to 0, you've got a function. Alright? Or x less than 0, you've got a function. Or you can restrict the range and domain and have a quarter of a circle. A quarter of a circle is still a function. A quarter of a circle is still a function. Correct? Or even if you like, if you restrict the domain from minus 1 to 3, and then the range from anything less than 0 or greater than 0, that is still a function, correct?
Yeah.
Just that bit is still a function. Or just that bit is still a function. Or just that bit is still a function. Alright? So you need to be able to think about how you could convert a circle to a function. If and when you need to do that. Alright? Now, the general equation of a circle is given as x minus b squared plus y minus q squared equals to r squared. I want you to notice the center of circle, which is PQ. Alright? In a few minutes, I will get all of you to start thinking about generalization. But in the meantime, grab your class bag out, please. If you haven't got a class bag, come and grab one for me.
You don't have a class
I've got some class bags here. Alright?
Oh, fuck, there was a spider on me. That's
Class bags. Now, this is a trick. You need to know how to use class bag to plot a circle.
Oh, what the fuck?
Alright.
Oh my god.
I need you to use your class bag to plot
That's hard.
x squared plus y squared equals to 9 and x minus 6 squared plus y plus 5 squared equals to 9. Alright. Now, could you do that with your class bag?
Yes.
How?
R equals, you rearrange.
Why,
Now, I'm going to show you one way of doing it without rearranging, alright? Alright, let me show you. I'm going to clear everything first. Alright? Now, let's go to main. Follow me, please. This is one other way of plotting a graph without going to graph and functions. Does any one of you know how to do that? Yeah, alright. So what you do is start off with the first one. X squared plus y squared equals to 9. Alright? And click execute. So that you've got the equation there. Make sure that you've got the right equation, x squared plus y squared equals to 9. Now, the next thing to do is to tap this little parabola button. Just tap it. Alright? And then make sure that what you need to do is clear all. Make sure that there is nothing there. Just clear it. Now, if you can't see numbers, all you need to do is go to graph format. And the grid axis on, line, on, and
What do you do?
coordinate set. Oh, actually, no, that's not right. I want the line. Graph format. I want line on rather than grid. Axis is on with number. Alright, set. You can see the numbers now. Alright? Now here, once you've got that done, you need to highlight. Highlight that bit. Not this one. You've got to execute first. Make sure that it's in the right form. Highlight and drag it down. Once you drag it, it will automatically draw it.
That's cool.
Alright? Once you drag it down, it will automatically draw it.
Calculations. This one.
I know, but I'm gonna put it.
Oh,
Maybe
you
it's a
have to
relation.
leave equals at the back. Oh, you got to click execute first. X squared. Execute.
It's nice, so it's no, there has to be this one,
Right now, all you need to do is clear all variables. Make sure that you clear all variables first. Now try the next one.
Why does this one give it this?
Invalid.
This whenever I execute.
Oops.
Don't do anything?
X minus 6 all square plus y plus 5 all square equals to 9. Now remember, you always have to click execute first so that you can see the correct equation. Drag it, highlight it, and drag it into the graph. Now, you've got only one graph at the moment. In order to add the other graph, what you need to do is highlight this again and then drag in. Now you've got two graphs. Correct? Have you got two graphs? Now, what I want you to think is, what is a transformation? How did I get from x squared plus y squared to x minus 6 squared plus y plus y all squared equals to 9? How did I do it? So where actually is the center now? Where did I move the center to? It's it negative 6 or positive 6? Well, think about it. You could zoom in. Alright, when I zoom in, because the scales is different, therefore it's became an ellipse. If you want, you can just put in tap in square, which means you know that it's circle now. So you've moved from here to here. So what is that point? So this is 0, 0. And this point is 1, 2, 3, 4, 5, 6. 6 minus 5. So what do you think the transformation will be? Alright? Hold on there. Keep the thoughts in yourself. I'm going to call out the other slides. Alright? So now, from my class pad, let's go to this. Alright? Alright, what's the translation involved? Let's look at this. I have gone from the red square to red circle to the blue circle. Right? You know that the center is 0, 0 and 6 minus 5. That's the translation. Would you be able to generalize it if I have given you x squared plus y squared equals r squared and get you to transfer it to that? How do you transform it? Are you able to generalize the transformation? You think so? Sorry? Sorry?
Negative y.
Don't know if this are.
Are you sure? Think about that. Negative y. Positive y became negative y. Negative 6 became positive 6.
Yeah.
So in a circle,
It's the opposite.
it's the opposite.
Yeah.
In a circle, it's the opposite. So the center is now translated to minus pq and minus plus q. So negative becomes positive. Alright, negative x becomes positive. Positive becomes negative. So for circle, if it is negative, it goes to positive. Positive, it goes to negative. Alright, and the radius remains at r. The reason why I said we are not doing dilation is we are keeping the radius as r. We are also not doing any reflection. So it's always same r, you're just doing dilation, that's all. No, sorry, not dilation, translation, that's it. Yeah? All happy with that? This is the generalization, that's important. So 2 more slides, let's have a look. The example, the point 14 lies on the verticals on the circle with the center 2, minus 3. Determine the equation of the circle and state its radius. Again, I will always sketch. Or for me, I actually drew it using, I think I used, I can't remember.
Desmos.
Could be Desmos, might not be, could be, I used Desmos, I used GeoGebra, and I used the other one, FX. 3 things. I can't remember which one I used. Now, here, what you need to do is work out what R is. Alright? So using Pythagoras Theorem, R is equal to square root of 1 minus 2 square plus 4 minus 3 all square. So therefore is 1 plus 4 minus 3 is 7. 7 square is 49. Is square root of 50. So therefore, the equation is x minus 2 square plus y plus 3 square equals to 50. Because we want r square. Alright? I could have worked out r square rather than r. It really doesn't matter. So if I work out r square, r equals to, could be, if I use the other way, r square equals to minus 3 minus 4 square plus 2 minus 1 square, which is 49 plus 1, which is 50. So you could do it this way as well, r square or look up r. It really doesn't matter. Alright, determine r or r square. Alright, last but not the least, example 5. Describe the features. What do we need to describe features?
Center.
Center and
Radius.
radius. So r square equals to 15. R therefore equals to square root of 15. And then center is minus 1 plus 9. That's all. So describe the features. That's it. All you need to know. Alright? So all what I want to teach you today is just basically all this. Justifying whether a circle is a function of relation. You should be able to determine the equation. You should be able to do the transformation now.